Hello. Today we are back at 220 Studios. Problem arose a few days ago when we filmed everything and the sound didn't work. And this is a short example of that. Here is some archive footage of that. So that didn't work. So we are coming back here today to just work on the exact same stuff we did the other day. And I think Dylan is busy inside the studio, so let's see what he's doing. Afternoon, Dylan.
Hello, Zach. How are you?
Welcome back to 220 Studios.
Catching up on my reading. Very good book.
Walking in my pocket.
Yes.
That's easily the best Dr. Seuss novel.
It is a classic.
Alright. Ready to get to work?
Yep.
Yeah.
Oh man.
So Dylan, what are we working on today?
We're working on And Your Bird Can Sing.
From what album and by what band?
Supposed to know this?
Yeah, you are supposed to know this.
Okay, it's by the Beatles.
Uh-huh.
It's Off Revolver,
Okay.
1966.
Oh, you're just using your cheat codes there.
No, I knew this. It's no big deal. What are you, like Cromwell star? Huh? Give me my spoons. This is a musical instrument. These aren't
No, you eat with these.
You don't eat with them.
Give me
You
that.
keep time in a bluegrass setting. You have no rhythm.
This is dumb. You're dumb for doing this. You're dumb. Let's just start the project. Hello. Today me and my associate Dillon Gilbert in 220 Studios, making up the band Delta, we're working on the physics of the band, which is pretty much the physics of music, which broken down even more is the physics of sound, which is actually pretty nice because there's a lot to explain and it's pretty easy to go about. So that's what we'll be doing today for your enjoyment. Sound is defined as vibratory disturbances in gas, liquid, or solid medium. Very simply, sound is the vibration of any substance. This substance could be air, water, wood, a penguin, or any material. When these substances vibrate or rapidly move back and forth, they produce sound. To be a little more accurate in our definition of sound, we must realize that vibrations that produce sound are not a result of entire volumes moving back and forth at once. If this were the case, an entire atmosphere would need to shift for any sound to be heard at all. Instead, the vibrations occur among individual molecules of a substance, and the vibrations move through the substance in a sound wave. As sound waves travel through the material, each molecule hits another and returns to its original position. The result is that regions of the medium become alternately more dense, and those are called condensations, and less dense, and these are called rarefactions, which can be easily interpreted on a graph such as this. There are four main parts of a wave: wavelength, period, amplitude, and frequency. The wavelength is the horizontal distance between any two successive equivalent points on a wave. That means that the wavelength is the horizontal length of one cycle of a wave. The period of a wave is the time required for one complete cycle of the wave to pass by a point. So the period is the amount of time it takes for a wave to travel a distance of one wavelength. The amplitude of a sound is represented by the height of a wave. When there is a loud sound, the wave is high and the amplitude is large. Conversely, a smaller amplitude represents a smaller sound. A decibel is a scientific unit that measures the intensity of sounds. The softest sound that human can hear is 0 point. When the sound is twice as loud, the decibel level goes up by 6. Humans speak normally at 60 decibels. Every cycle of a sound has one condensation, or region of increased pressure, or one rarefaction, a region where air pressure is slightly less than normal. The frequency of a sound wave is measured in hertz. Hertz indicate the number of cycles per second that pass through a given location. If a speaker's diaphragm is vibrating back and forth at a frequency of 900 hertz, then 900 condensation are generated each second, each followed by a rarefaction, forming a sound wave that's frequency is 900 hertz. How the brain interprets the frequency of an emitted sound is called pitch. We already know that the number of sound waves passing through a point per second is the frequency. The faster the vibration the emitted sound makes, the higher the pitch. Therefore, we know that the E has a lower pitch than the B. Go.
And now for a brief history on the drums. When it was discovered that one player could play two or more types of drums at the same time, people started placing the groups of drums together for one musician to play. These groups were comprised of an assimilation of drums of different cultures and from all around the world and globe. Cymbals and tom-tom drums were brought in from China, with the size being adjusted to allow for ease of play when played with drumsticks. It was not until the early 1930s that drummers slowly discovered with the proper drum placement and a lot of practice, one musician could handle a set of drums and an entire band or drum players was not required anymore. Thus the basic kit was born and evolution took place. In the 1950s, as rock and roll music became more developed, the sounds became more complex, and likewise the drum sets became more evolved, with new additions added to them. Rockers began expanding the drum kits by adding more cymbals and tom-tom drums to them.
The speed of sound. Sound travels at different speeds depending on what the medium is. Of the three mediums, solid, liquid, and gas, the gas is the one where sound travels the slowest because the molecules are so spread apart that it takes the molecules a lot of time for them to hit each other. They travel the fastest in solids because they're so packed together that it takes literally no effort at all for the molecules to hit each other, and that's why sound travels so fast in solids and not that fast in gas. It's pretty.
Thanks. And now for a brief history on the piano. In the early 1700s, Gottfried Silbermann invented the precursor to the modern damper pedal, which lifts the dampers from all the strings at once. Vienna's pianos of the 18th century, often referred to as forte pianos, incorporated wood frames, 2 strings per note, and used leather-covered hammers. This gave them a softer, clearer sound than today's pianos, but with less sustain. From the late 1700s to the early 1800s, iron frames came into use, allowing up to 3 strings per note, as did steel pianos' wire strings. Felt hammers began to replace the earlier leather-covered versions in 1826. Damper and sustento pedals were perfected, and the keyboard grew from 5 octaves to the modern 7.5 octaves or more. There really weren't a lot of major changes in the piano over the last 200 years. Okay, I'm going to warn you, this thing hasn't been tuned since the 40s.
The 1840s.
Yeah. So, just bear with it.
Whenever condensation meets a condensation, or a rare fraction meets a rare fraction, there is a constructive interference and the amplitude increases. When a condensation meets a rare fraction, or vice versa, there is a destructive inference and you can hear nothing. This periodic variation in loudness are called beats.
1,
5, 6, 7, 8.
That's dancing.
1, 2, 3, 4.
Tell me that you got everything you want, and your bird can sing, but you don't get me. You don't get me. You say you've seen 7 wonders, and your bird is big, but you don't get me. You don't get me.
Dang.
Alright, I think this is enough.
Yeah.
And now for a brief history on the bass guitar. The bass guitar is lower in pitch than the electric guitar on which it is based. It was designed to provide double bass players with a portable, fretted instrument which could be amplified and easily played. The bass guitar has 2 important roles in a band. It plays bass notes to support the melody, and along with the drums, it provides a rhythmic pulse that drives the band along. The bass guitar is part of the string family and was invented by American Leo Fender and first marketed in 1951. It was soon very popular with country and western players. It is made from a mixture of wood, metal, and plastics, and the average size would be about 3 foot 8 inches long. Bass guitars also support amplifiers, fuzz boxes, echo units, and pedals. The classification of the bass guitar is under quarterphones, as it produces its sound from the vibration of strings. Alright, I'm going to warn you about slap bass.
An obstacle is no match for a sound wave. The wave simply bends around it. For example, if a stereo is playing in a room with an open door, the sound produced by the stereo will bend around the walls and go into the opening. The bending of the wave is called diffraction.
Tell me that you got everything you want, and your bird can sing, but you don't get me. You don't get.
Let's keep going. We're friends. It's well understood. Haha.
Yo. Alright.
My microphone.
When your bird is
No! Hold on. Okay, let's start at the beginning.
Alright.
We're getting after this.
Yeah. Later.
You knew exactly what I was trying to do.
Yeah, I know. I saw you setting up for it. I'm like, nope.
Cut. You're ridiculous.
You're
white.
You're so white, Toby.
So white.
How do you stop this?
Cut. Keeping that.
Here. Alright. See? Now for a brief history on the guitar. The earliest stringed instruments known to archaeologists are bowl harps and tamburs. Since prehistory, people have made bowl harps using tortoise shells and calabashes as resonators, with a bent stick for a neck and one or more gut or silk strings. The Europeans added frets to the oud and called it a lute. This derives from the Arabic alud, literally meaning the wood, via the Spanish name laud. A lute, or oud, is defined as a short-necked instrument with many strings, a large pear-shaped body with a high vaulted back, and an elaborate sharply angled peghead. The name guitar comes from the ancient Sanskrit word for string, tar. This is a language from which the language of Central Asia and Northern India developed. Many string folk instruments exist in Central Asia to this day, which have been used and almost unchanged for several thousands of years.
Let's go!
Bing, bonk. Stop. Go.
Oh, okay.
You want to do your walking?
No, I'm fine.
Alright, go ahead.
So that was our physics project. I hope you enjoyed it. We learned a lot about the physics of sound and music, such as wavelengths and periods and frequency and pitch and things of that nature. Learned a lot about the history of instruments, and we got to see Delta perform, which is a treat. And I'd say that we learned a lot about friendship today. I feel like that was a key component.
It was a good experience, and hope you enjoyed it. New album will be coming out, hitting bookshelves, music shelves. It'll be coming out soon.
It'll be the public library.
It won't be there. Okay. Anyway, I hope you enjoyed it, and coming back for more. All right,
nailed the joke.
Or something.
All right. This is Delta's new single, "Walk It in My Pocket." It'll be on 18 seconds. Going out to bookshelves near you.
Come on, man.